Good evening, scholars. Welcome back to another live class. This is our CSEC class. It's Tuesday, and so you know, today is for algebra, our favorite, absolute favorite topic, rather, in math. Tonight, in algebra, we're going to be looking at one of the most useful and popular of the algebraic procedures, and that is the distributive law or the distributive property. Right? Very popular, very well used in algebra, and one way of saying it is we expand the brackets, right? So if you look at the image on the screen, it says the distributive property or distributive law, A bracket B plus C bracket is equal to plus AC, and A bracket B minus C bracket is equal to AB minus AC, where A, B, and C are real numbers. Now you're wondering, why are they talking about real numbers? Are there numbers that are not real? Well, yes, in maths, there are numbers that are not real, but you don't need to concern yourself with those at this level. There are what you call imaginary numbers. But here we're focusing on the real number system, right? So what this is saying is that the number or term or variable, whatever is in front of the brackets, we multiply that by whatever is inside the brackets. And that's what we mean by we expand the bracket. So that's how we get from A bracket B plus C. We multiply the A times the B, and we get AB. We multiply the A by the C, and we get AC. Likewise, for the subtraction part of it, A bracket B minus C bracket. So it's A times B, which gives AB, and A times C, or more to the point, A times negative C, which gives negative AC. Let's look at another chart. Just expands this a bit. So the distributive law is also called foiling. So we say that we're going to foil the brackets. And what we do is it's like we're splitting the terms apart. So in this case, we have two brackets, right? And it's the same procedure. Everything in the first bracket is multiplied by everything in the second bracket. So it will be the x times the 2x. You can look at it several ways. You can say the x times the 2x minus 1 and the 3 times the 2x minus 1, which is what they have done in this method. Or you can say, all right, so it's the x times the 2x and the x times the minus 1, and then 3 times 2x and 3 times minus 1. So what we get eventually, x times 2x is 2x squared, and x times negative 1 is negative x. The 3 times 2x gives 6x, and 3 times negative 1 gives negative 3. And then what we do is we simplify. Now there's an error in this on this chart. They have 2x, it should be 2x squared because nothing was done to the 2x squared. It's still 2x squared. And they simplified the negative x and the 6x, so we get 5x, and then we have the negative 3. Some persons like to put arrows. So that when I'm going to do some examples on the board. For some of them, I'm going to put the arrows just to show you. But you don't have to put the arrows. If it feels better to you, if it helps you to remember and to understand it better, you can go ahead and use your arrows. On this chart, you notice that we have the blue. They don't actually use an arrow, they use more of a rectangular looking thing, but it serves the same purpose. So it shows you you're going from the x to the 2x, you're multiplying that, and that's how you get the 2x squared. And then the x to the -1, which gives the negative x. Then the purple one is showing the 3 to the 2x, which gives 6x, and the 3 to the -1, which gives -3. Same answer as before. Okay. So what I'm going to do now, I'm going to stop sharing, and I'm going to go to the board, and let me fix this so you can see the board properly. I hope you're seeing it. Are you?
Miss, it's not clear. Like, I can see the questions, but it's not like clear.
Okay. Well, I'm going to be calling the terms as I go along. And what I'd like for you to do, as I call the terms, I want you to write it in your book.
Yes, miss.
Okay? Since you're not able to see it clearly, so I'm going to be talking as I go along. Okay, welcome, Zion. I'm going to be talking as I go along. So as soon as you hear me say something, you write it down. And that way we'll all be on the same page. So I'm going to work them. I have several of them on the board because I wanted to make sure to include all or at least most of the examples that you're going to be seeing for the distributive law. So here we have a very simple example. We have 2 brackets 3x plus 5 brackets. So remember we said for the distributive law, whatever is in front of the bracket, we multiply that by what's inside the bracket. So it will be 2 times 3x, which is 6x, and 2 times 5, which is
5 is positive
and it's a
10.
positive 10 because it was a positive 5. All right, as easy as that. So 2 times 3x is 6x, 2 times 5 is 10. Now that cannot be simplified because we cannot add x term with a whole number, with a
Yes.
constant term. They are not like terms, we can't add them. So this is as simple as it gets. And that's our answer. For
Yes.
number 2, what we have is -5 on the outside,
Yes.
bracket, 9x minus 1, close bracket.
Okay, miss.
So -5 bracket, 9x minus 1, close bracket. So we're going to multiply the -5 by the 9x. So I'm going to put the arrows. So -5 times 9x, that's a
That is
negative
-45x.
x. And another arrow from the -5 to the -1. So
Negative
-5
times
times
negative,
-1,
+5.
that will give a positive 5. Negative times negative would be positive. And that's our answer there. When we are doing factorizing, we're going to see that factorizing is like the opposite of using the distributive law because we get from here to here.
Yes, miss.
So we would remove back the factors, pull out the common factors, and whatever is left back, we put it in the bracket. With the distributive law, we expand the brackets and then we are left with the terms. For number 3, I have 6 on the outside bracket, 3y plus 2x plus 9, close bracket. So we have three terms on the inside. Outside we have positive 6, open bracket, 3y plus 2x plus 9. So we're going to multiply 6 times 3y, which is
18y
18y, 6 times 2x, which is
is 12x
12x, and 6 times positive 9, which is
positive
positive
54.
54. And that's our answer. That's a
Yes,
fact.
miss.
We can't simplify them because we can't add an x to a y. They are different terms. We can't add 54 to an x or to a y. They are all different terms.
Yes, miss.
Number 4 has fractions. So there's a half bracket, 8x plus 4y, close bracket.
Yes, miss.
Even though you see a fraction there, some persons get scared if they see fractions or decimals. It's the same principle. We're multiplying a half by 8x. Half of 8 is 4. So a half times 8x is 4x,
4x
and a half times 4y is
is 2y.
2y, because half of 4 is 2. So the answer is 4x plus 2y. Number 5, we also have a fraction, which is 3 quarters.
Miss, can you just put it down a bit?
Yeah, that's it. So that's 3 quarters on the outside.
Yes, miss.
Open bracket, 20y minus 10, close bracket. So 3 quarters, open bracket, 20y minus 10, close bracket. So 3 quarters of 20. 3
Miss,
quarters
15.
times
15y.
4 into 4, 1, 4 into 25. So that's 15y, right?
Yes, miss.
And 3 quarters times negative 10.
Miss, that's 7 and
So that's 3 times negative 10 is negative 30 over 4.
oh, negative. Yeah, negative.
Yeah. So
Which is
4 into 30 goes 7
7
times.
times
Remaining
remainder
2, right?
2 over
So
4.
that's 7.5.
Yes, miss.
So don't be scared of fractions. So it's 15y minus 7.5. Or we could have put the 15 over what? 2. Reducing the 30 over 4. So you could leave it in that form. Alright, up to the top now. Number 6.
Okay, miss.
We have 5 on the outside bracket. 6x plus 3, close bracket, and then we have a negative 4 to the
Okay.
right. So we have 5 times 6x, which is 30x,
30x.
and 5 times 3 is 15.
Yeah, minus 4.
So what do we do with the minus 4?
Miss, we subtract it from 15 because they're
So
both
we
real
just write it
numbers. They
back.
don't have any variable.
So why not multiply it by the numbers inside the brackets?
Because we're supposed to multiply what's in front the bracket by what's inside the bracket, and 4 isn't
So
in
are you
front or
saying we
inside.
can't multiply what's behind the brackets? Is
No,
that
miss,
the
we
reason?
cannot.
We could if there was a number just exactly is like attached to the bracket the way the 5 is attached on the left hand side. It could work like that, but this is separated by a minus, right?
Oh, okay.
Okay,
Gotcha.
so
If it was a
if
plus,
it's
that would have like
separated by an operation, subtraction or addition, we can't work it with the brackets. But we can simplify this, right?
yes, miss.
So we can take the 4 from the
From the
15.
15, which is 30x plus 11.
Alright, 30x plus 11. Alright, now number 7, we have 2 brackets and we have a 9 in front. So it's 9 times 9 open bracket, x plus 5, close bracket.
Yes, miss.
And another open bracket, x minus 3, close bracket.
Okay, miss.
So we have to expand one set first and then we expand the other, right?
Yes, miss.
So we can either work the two brackets first and then the 9 or the 9. So I'm gonna work the 9 with the first bracket.
Yes, miss.
So 9 times x is 9x and 9 times 5 is
It's
45.
45.
We bracket that and then expand the other brackets. No, right?
Yes, miss. Yes, miss.
So 9 times x, 9x times x is
Is
9x
9x squared.
9x times negative 3 is negative
Negative 27.
27x. 45 times x is 45x. And what's 45 times negative 3?
Um,
That's what? Negative 135?
yeah.
Yes,
Yes,
miss.
miss.
Okay. Can we simplify this?
Yes, miss.
Yes,
The
miss.
two x's can be you
So
can add
we have the
this
same
negative
term. They are both x's. We can combine them, right?
Yes, miss.
So we write back the 9x squared and put negative 27x plus 45x.
18x.
Is it a negative or positive 18?
Positive, miss, because the larger numbers are positive.
So positive 18, and then we write back the negative 135. Is that clear?
Yes, miss.
Any questions?
No, miss.
Okay. Okay. All right. Number 8, we have two brackets as well. We have 2x plus 6 in one bracket, x minus 4 in the other. So we're going to expand now 2x times x, that's 2x
It's 2x
squared, and 2x times negative 4 is negative
negative 8x.
8x. 6x times x is a positive 6x, and 6
Miss,
times
6
x,
times x is positive
yeah,
6x.
and 6 times negative 4 is negative
Negative
24.
24.
Can we simplify?
Yes, miss. Negative 8x plus 6x.
And that gives what?
Negative 2x. So the
So we
final
write down the
expression would
2x squared because it's the only term with an x squared. There's nothing to
yes,
combine it with. But we can combine the negative 8x and the positive 6x. We get negative
negative
2x
2x
and write back the 24.
minus 24. Yes, miss.
Yeah. So I'm saying, so this is a quadratic expression.
Yes, miss.
If we were to factorize it, it would bring us back to the
Back
original
to
thing
yes,
here,
miss.
right? So we would have found out that the negative 8 and 6 are factors of negative 24, which add to give negative 2. So we'd split it up and then factorize this pair and that pair. So you see that it's the reverse process.
Yes, miss.
So number 9, two brackets again.
Yes, miss. So it makes 3x squared.
So 3x times x,
Yes, miss. 3x squared.
3x squared, and 3x times 3
Is 9x.
and 9 times x,
9x.
and 9 times 3.
Positive 27.
So now we're going to simplify the middle because they are both x's. We can combine them.
Yes, miss.
So we have 3x squared and 9x plus 9x is
Is 18x. Positive 18x.
positive 18x
Yes, miss.
plus 27. Any questions?
No, miss.
Right. The distributive law is pretty simple, and like I said, it's pretty popular. Everybody loves it. And commonly used in algebra. All right. So we have 3 to go.
Oh.
So what are we to do now?
Miss, we're
Number
supposed to
10.
multiply everything in the bracket by the negative 1 because that's what's exactly in front.
So what about the 3?
Mr. 3 is going to remain there
Because
because it's not directly in front of the bracket.
It's because
right.
the negative is in front of it.
All right, so the 3 is separated from the bracket by a minus sign or a negative sign. So as Imani says, there's actually, it's like there's a negative 1 here in front of the bracket. So we write back the 3. Negative 1 times x is,
Negative x.
and negative 1 times 6.
Negative 6.
Can we simplify?
Yes, miss. Miss, positive 3 and negative 6.
All
And
right,
that
so
would
the
give you
3 and 6, they are
both
constant terms.
constant terms. Yes, miss.
So it's negative x, and then 3 minus 6 is
Negative 3
negative x minus 3.
minus 2.
All right, how about number 11? We have x plus 5 minus bracket 4x plus 2 bracket.
Since the x and the 5 would stay, miss, and then we'll use the negative one to multiply what's in the bracket.
So we write by the x and the 5. Negative 1 times 4x is negative 4.
Negative 4x.
Negative 1 times 2 is negative 2.
Negative.
How would we simplify that?
Miss, positive x, well, x minus 4x would give you negative 3x, and 5 minus 2 would give you positive 3.
Correct. So x minus 4x is negative 3x, and 5 minus 2 gives
Positive 3.
positive 3. Okay, last one. This time we have 2 brackets with terms in front.
Yes, miss.
So we're going to expand each one and then simplify, right?
Okay.
Yes, miss.
Expand each one. So 6 times x,
6x,
and 6 times 9,
positive 54,
and negative 4 times 2x,
is negative 8x,
and negative 4 times positive 2.
negative 8.
Alright, so how do we simplify now? We group the
6x,
x's.
yes, miss.
We put x
Together.
minus
Minus
8x
8x,
It's that would be negative 2x.
would give negative 2x.
negative 2x,
And 54 minus
4
8
minus 8,
It's that would be about.
um,
Oh, miss
miss
46.
42.
46.
Is 46? Wait. Miss, yeah,
Am I
46.
right or wrong?
46, miss, 46.
Yes,
Okay.
correct.
Alright, so you see that it's pretty straightforward, isn't it?
Yes,
Yes,
miss.
miss.
If that was.
And we use it a lot. So the distributive law is gonna come in handy when you're asked to expand and simplify, as we did tonight. It's going to come in handy when you're factorizing, because it's the opposite of factorizing. And anytime you need to expand your bracket, anytime you're given brackets and you need to do any kind of simplification, the distributive law is definitely your go-to law. um and yeah, that's it. That's pretty much it. Do you have any questions
No,
about
not
this law?
No.
So to recap, let's just look back at the 2 charts that we have. So this chart, and remember, it's also called the FOIL method. Usually, well, as far as I know, that's the American term. Just like how we would have
BOMDAS and they have PEMDAS.
BODMAS. Yeah, we would have BODMAS or BOMDAS, and the Americans would say PEMDAS, but it's pretty much the same thing, right?
Yes,
It's just pause.
Yeah, it's called the foiling method. And whatever is in front of the brackets, immediately in front, not separated by a plus or minus sign. Or if you have 2 brackets in front of each other, as you see on the screen here, so you'd multiply everything in each bracket by
yes,
everything in the other.
we're not seeing the
Oh,
screen.
I forgot that I had stopped sharing. I'd stop sharing so you could see the board. So let me go back. Okay. Seeing it?
Yes,
Yes, miss.
miss.
All right. So we have, so this is the case of having two brackets, right?
Yes,
Yes,
miss.
miss.
So it's the x times the 2x, the x times the negative 1, 3 times the 2x, 3 times the negative 1. And then we simplify by combining the like terms. And that's as simple as we can get it. And the other one was just showing you the law, but just using variables, not using any actual numbers.
Yes,
Yes, miss.
So in its simplest form, the distributive law is A bracket B plus C bracket is equal to AB plus AC, or A bracket B minus C bracket is equal to AB minus AC, where A, B, and C are real numbers. And at this level, we're only concerned with real numbers. All right, so remember tomorrow is what, Wednesday?
formula.
Wednesday,
With
miss.
formula
No,
class.
that's Thursday.
Oh,
So that's formula class. All right. So last week, which form did we feature?
Pythagoras theorem.
Pythagoras' theorem.
Pythagoras' theorem. Okay. So tomorrow we have another special formula. So make sure you tune in for that class. And it's really good when you know your formulas and know which one to use and when to use it and why to use it. It goes a long way in solving your problems in math. So thank you, scholars, for being
Yes.
my studio crew. Thank you as always, and those on the chat typing in your answers. Thank you also for sharing the time and the space with us. I'll see you tomorrow.
See
Please
you
remember,
tomorrow,
we're
miss.
not just solving math problems, we're changing lives. Goodbye.
Oh, yes, we are. Say that again.
Please remember, we're not just solving math problems, we're changing lives.
Exactly. So Amari says, we're not just solving math problems, we're changing lives. And, you know, it reminds me of, we just had a PEP class and we're looking at the stem and leaf plot. And so many students were saying it's the very first time they're seeing the stem and leaf plot. And now, by the end of the class, they understand completely. So, yes, we do change lives. And yes, stick with us. You're in good company. You're in excellent company. I'll see you tomorrow.
See
See
you
you tomorrow,
tomorrow,
and I'll
miss.
see you in the next video.
See you in the next video. My scholars are so sharp.